Have you ever looked up at the night sky, at all those countless stars, and wondered, are we alone? It's a question that has captivated humanity for centuries. Our own galaxy, the Milky Way, is home to hundreds of billions of stars, and there are hundreds of billions of galaxies in the observable universe. The numbers are just staggering. Given this sheer scale, it seems almost statistically impossible that Earth is the only planet to have spawned intelligent life. So, where is everybody? This is the heart of a fascinating and slightly unnerving puzzle known as the Fermi Paradox. The paradox is named after the brilliant physicist Enrico Fermi. The story goes that back in 1950, during a casual lunch conversation at Los Alamos National Laboratory, Fermi suddenly blurted out, "But where is everybody?" He was pondering the high probability of extraterrestrial life and the complete lack of evidence for it. Let's break down his thinking. Our Sun is a relatively young star in the grand scheme of the universe. There are billions of stars in our galaxy that are much, much older, billions of years older. If we assume that life isn't a miraculous one-off event that only happened here, then it must have arisen on other planets around some of these older stars. If a civilization had a head start of, say, 1 billion years on us, what would they be capable of? Think about how far our own technology has come in just the last 100 years. A civilization 1 million years or 1 billion years ahead of us would likely have technology that seems like magic to us. They would have had more than enough time to solve interstellar travel and start colonizing the galaxy. Even with technology that's not much more advanced than our own, a civilization could colonize the entire Milky Way in a relatively short amount of time. Cosmically speaking, estimates range from a few million to tens of millions of years. Now, that might sound like a long time to you and me, but on the cosmic calendar, it's just a blink of an eye. So, the galaxy should be teeming with alien civilizations. We should see signs of them everywhere. Their probes, their megastructures, their radio signals something. Yet, when we scan the skies, all we get is silence. An eerie, profound silence. That's the paradox, the high probability of alien life versus the total lack of evidence. So, how do we solve this? Scientists, thinkers, and science fiction writers have proposed a whole range of fascinating and sometimes terrifying possible solutions. Let's dive into some of the most popular ones. One of the most straightforward, if a bit lonely, solutions is the rare earth hypothesis. This idea suggests that while simple microbial life might be common throughout the universe, the chain of events that led to complex, intelligent life like us is incredibly rare. Think about all the things that had to go just right for us to be here. We have a stable star, the Sun. Our planet is in the Goldilocks zone, where water can exist as a liquid. We have a large moon that stabilizes our axial tilt, giving us stable seasons. We have a magnetic field to protect us from solar radiation. We have plate tectonics to regulate our climate. The list goes on and on. Maybe the combination of all these perfect conditions is so statistically improbable that we are, in fact, the only intelligent species in the galaxy, or even the universe. It's a humbling thought. But what if we're not alone? What if the aliens are out there, but they're just not talking to us? This leads to a whole other set of possibilities. One is the zoo hypothesis. In this scenario, advanced alien civilizations know we're here, but they've decided to observe us from a distance like we observe animals in a wildlife preserve. They've established a kind of cosmic quarantine around us, a do not disturb sign for planet Earth, to allow our civilization to develop naturally without interference. They might be studying us for scientific or even ethical reasons. We're simply a galactic nature documentary in progress. A slightly different take on this is the prime directive idea, borrowed from Star Trek. Perhaps there is a galactic rule that advanced civilizations are forbidden from contacting less developed ones until they reach a certain technological or ethical milestone, like achieving warp drive or world peace. We just haven't passed the test yet. Then there's the communication problem. Maybe we're listening for the wrong things. We're scanning the skies for radio signals because that's the technology we use. But a civilization millions of years more advanced might be using a form of communication we can't even imagine, like modulated gravity waves or some kind of quantum entanglement messaging. Using radio to search for them might be like trying to find a modern city, using only a smoke signal detector. The signals could be all around us, but we lack the senses to perceive them. Or perhaps they did send signals, but we missed them. They could have sent a probe to our solar system millions of years ago, saw a bunch of dinosaurs, and moved on, leaving a nothing to see here note in their galactic travel guide. By the time we evolved and started looking, the cosmic tourists had already left. The timing just wasn't right. Now, let's venture into some of the darker, more unsettling possibilities. This is where we encounter the idea of the Great Filter. The Great Filter is a proposed barrier or challenge that is so difficult to overcome that it prevents most life from ever reaching an advanced stage. The question is, where in the timeline of life does this filter lie? One possibility is that the filter is behind us, maybe the leap from non-living matter to the first simple cell, or the leap from simple cells to complex multicellular life is the Great Filter. If that's the case, we're incredibly lucky. We've passed the test. It would mean that microbial life might be common, but complex life like ours is exceedingly rare. This would be a relief, suggesting a bright future for humanity among the stars. But what if the Great Filter is ahead of us? This is a much more frightening thought. It would mean that many civilizations may have risen to our level of technology, but something inevitably wipes them out before they can colonize the galaxy. What could this filter be? It could be self-destructs through nuclear war, an ecological collapse from mismanaging a planet's resources, a runaway artificial intelligence that turns against its creators, or even a technological accident we haven't even conceived of yet. If this is true, then the silence in the cosmos is a warning. It's the silence of a graveyard. Every civilization reaches a certain point and then goes extinct, and we might be next. This leads to the Berserker or Dark Forest hypothesis, which is perhaps the most paranoid and terrifying solution to the Fermi Paradox. This idea, popularized in the sci-fi novel The Dark Forest, suggests that the universe is a dangerous place. Any civilization that reveals its location by broadcasting signals into space is essentially screaming, "I'm here. Come and get me," to potential predators. The wisest strategy for any intelligent species is to stay silent and hidden, because you never know who or what might be listening. In this scenario, the sky is quiet not because it's empty, but because everyone is hiding from each other in fear. Any civilization foolish enough to make its presence known is quickly exterminated by a more advanced, paranoid predator to eliminate any potential future threat. So, our broadcasts into space might be the dumbest thing we've ever done. So, where does this leave us? We're left with a spectrum of possibilities, from the optimistic and lonely to the truly terrifying. We could be the first, the rarest, or just the next in a long line of civilizations destined for oblivion. The truth is, we don't know. The Fermi Paradox isn't a problem with a single answer. It's a mirror reflecting our hopes, our fears, and our profound ignorance about our place in the cosmos. But the search continues. Projects like SETI, the search for extraterrestrial intelligence, continue to scan the stars, and new telescopes like the James Webb Space Telescope are giving us an unprecedented look at distant exoplanets, searching for biosignatures in their atmospheres. Every new discovery could bring us one step closer to answering that profound question. Are we alone? Whether we find out we're the only ones, or that we're part of a vast cosmic community, the answer will change everything about how we see ourselves and our future. The silence is profound, but it doesn't mean no one is out there. It just means we need to keep listening, keep exploring, and keep wondering. The universe is a big place, and the story is far from over. Thanks so much for watching. If you found this cosmic mystery as fascinating as I do, be sure to hit that like button and subscribe for more deep dives into science and the universe. What do you think the answer to the Fermi Paradox is? Let me know in the comments below. See you next time.